production now. Thank you.
Okay, thank you and good afternoon, everyone. My name's Steve Anderson. I'm served as the Dean of the UIUC School of Social Work. Thank you for joining us for our second presentation this semester in our lecture series on harnessing technology for the social good. This series was created to promote innovative research and technology applications to more impactfully reach highly vulnerable groups who face some of the most vexing social problems in our society. Today, I'm very pleased to welcome Dr. Eric Rice as our speaker. Dr. Rice is Associate Professor in the University of Southern California Dvorak Peck School of Social Work. He also serves as the founding co-director of the USC Center for Artificial Intelligence in Society, which is a joint venture between the School of Social Work and the USC Viterbi School of Engineering. Dr. Rice is committed to community-based participatory research, and he has worked closely with many community-based organizations, primarily on issues of HIV prevention for homeless youth and impoverished families affected by HIV. He's an expert in social network theory, social network analysis, and the application of social network methods to HIV prevention research. He recently focused on developing an online social networking HIV prevention program for homeless youth, with funding through a grant from the National Institute of Mental Health. It brings social network theories and models to bear on the social problems faced by homeless youth and families affected by HIV. Today, Dr. Rice will be discussing his recent work in collaboration with computer scientists to improve HIV prevention interventions for youth experiencing homelessness. He will discuss the interplay and co-evolution of algorithms and fieldwork over 4 years to develop and ultimately test the efficacy of a new AI-augmented intervention with more than 700 youth. He will also discuss the complexities and opportunities of interdisciplinary collaborations in the space of technology for the social good. Eric, thank you very much for joining us.
Thank you, and thanks for that kind introduction. Let's see, I'm gonna flub technology, no doubt. Oh, no, don't leave. Cancel. I see, I almost left. Share screen, that's the thing, that's the button. Don't press the big red button, Eric. Okay, here we go. Gonna get onto my PowerPoint, and so is this okay? I got the thumbs up. God, you know, you start an AI center and people expect you to be able to work technology, and instead I'm kind of a Luddite. Okay, so now that I've got myself grounded, so this afternoon in the Midwest and East Coast, and this morning still in the West Coast, I'm going to be talking about my work as Dean Anderson suggested, working with computer scientists to do a new HIV prevention intervention that's augmented by AI. And I'm going to talk a lot about insights from algorithms to the field and the hard work it takes of interdisciplinary collaborations to make something like this happen, but also the potential power that it has. So when I talk about artificial intelligence, a lot of times people think that I'm talking about something like this, you know, killer robots, the Terminator, but in fact, I'm really talking about stuff that's way more mundane, like this, you know, Google search. So, you know, when you type in a search like I did here, what is RT, you know, it gets to what is artificial intelligence very quickly, because, you know, the algorithms have learned what I and people like me are looking for. And so there's a whole series of predictive analytics that go into this kind of technology. But there's also technologies like this, Uber and Google Maps, that are actually more akin to what I'm going to be talking about today. These are what we might think of as optimization algorithms. So think about Google Maps for just a minute. What you have is a messy network of streets filled with traffic that's being updated in real time in data. and an algorithm is trying to give you an optimal solution about how to get from, say, in my case, the LAX airport to USC campus, which is something that I used to do a lot prior to 9 months ago. And so this is, you get some alternate versions, and it gives you some predictions about what that might be like. And this is a very useful thing because, it would be very, 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 very difficult, if not impossible, for a human being to give you such an accurate prediction. But computers are very good at processing this large quantity of data and providing you with these potentially optimal solutions. So this is the kind of work that we engage in at the USC Center for Artificial Intelligence and Society. And what we really think about is this is a three-way partnership between engineering, social work, and our community partners. And we're really thinking about this as work that is intended to be a merger between these two seemingly disparate disciplines to try to bring together solutions to really, really challenging, complex problems like homelessness, like suicide prevention, HIV prevention, substance abuse treatment, wildlife conservation. I mean, these are some of the things that we're thinking about. And sometimes people think that this is sort of a crazy combination, engineering and social work, like we're talking about, pouring, maple syrup on sardines or something awful like that. But it's really a little bit more like bacon wrapped dates. It's a little weird, but when you first try it, then it's really awesome once you start to get into it. And part of that is because both social workers and engineers as practitioners are problem-focused people who work on real-world problems. So academics within social work and within engineering and computer science are also people who are very much focused on solving problems and solving practical real-world problems. So this is a little picture of my colleagues that are part of the core leadership of the center. This is myself, my co-director, Bistra Delkina, who's another associate professor in the Viterbi School, Jordan Davis and Phoebe Vianos, who are both associate directors and assistant professors in engineering and social work. And one last kind of bad joke that I'll throw out at the beginning here is that, one of the cool things about this center is that the two dudes with the long hair and beards are not the computer scientists. They're actually the social workers. It's the women who are the computer scientists, because we like to do things a little bit differently at CASE. And so what do we work on specifically? I mean, these are the 7 core areas that the CASE team is working on. So prevention of substance abuse and treatment of substance abuse, disaster planning, community resilience, a lot of sort of the grand challenge for the human impact of global climate change plays into that. Promoting well-being, there's a number of grand challenges of social work that play into that. Suicide prevention, fairness, equity, and bias. Obviously, there's a lot of grand challenges around fairness and social justice and equity. And then homelessness, and there are certainly the grand challenges of homelessness out there, as well as obviously all of this ties into the grand challenge of technology for social good. Now, as I mentioned, what we like to do in this center is really to think about how to work with community and work with engineering and work with social work. And the process of this in terms of intervention design really is a loop. It is not something that's just a one-shot thing wherein you come up with some brilliant idea and you test it and it's perfect. In fact, figuring out how to bring computer science and social work together in impactful ways is an iterative process, as almost anything in social work is. But what we find is that what we do is first we work on possible algorithmic solutions, then we field test those algorithmic-based solutions, and then we realize what new implementation challenges are in the real world, and then we go back to the redesigning process again and keep iterating on this until we get to where we want to go. Okay, so enough of talking in generalities. Let's get down to what this is really about. So HIV prevention among youth experiencing homelessness. So what we find is from some of the work that came out of the University of Chicago, Chapin Hall, is that there's about 4.2 million youth and young adults, teenagers and young adults from 13 to 24 who experience at least one night of homelessness every year. Los Angeles has and has consistently had since about 2016, 17, about 60,000 people experiencing homelessness on any given night. And the numbers of those that are youth 13 to 24 ranges anywhere from about 3,500 to about 6,000, depending on the year. We did at the very beginning of this study, we did some epidemiologic type work and found that based on self-reports, 7% of the youth that we sampled in Los Angeles were aware of their HIV positive status, which it dwarfs what you find in the general population of housed youth of the same age, where the rates of HIV infection are less than 0.3%. So this is, a wildly disproportionate problem. The CDC has considered anything above 3% to be an epidemic level of HIV in any given population for years. So this is considered to be an epidemic amongst homeless youth. Now, this is a picture of what you might imagine homeless youth in Los Angeles look like, right? A bunch of young people sleeping on the streets near the beach, sleeping bags and shopping carts and other sort of detritus of homelessness. And this is not an entirely inaccurate picture of homeless youth, but here's another picture of homeless youth that I think is an even more important picture to share. And this is the network of homeless youth. And the colors represent some social cliques, and the lines between these squares represent connections between these young people. And what's really important to understand about homeless youth is that these are incredibly disadvantaged young people. It's important to realize that about 40% of the youth who are experiencing homelessness in Los Angeles are Black youth. About half of the youth who are experiencing homelessness in Los Angeles have been in the criminal justice system, mostly in juvenile justice, but also in adult justice system. We also have about 40% who've been in the foster care system. We have about 40% who are LGBT youth, most of whom have either run away from very unwelcoming family experiences or who have been thrown out of home. And the way that these young people survive on the streets day in and day out is because of this map that we're looking at right now, which is the connections to one another. It's through other youth on the streets that young people find safe places to spend the night where they won't be victimized. It's where they find out about how to get free food. It's where they find out about how to get connected to social services. Some of the social service drop-in centers that I work with don't actually even do any street outreach because the community of homeless youth is so active and involved in sharing information about resources with one another that they have no need to, because the youth themselves do that work for them. Now, with respect to HIV, one of the things that we're really interested in doing as social work researchers and practitioners that are sort of working on the edges of public health problems is HIV prevention, because of the huge numbers of HIV cases. And one of the models that has been proposed as potentially a viable solution for this group of young people, given the network connectivity of these youth, is to do what is referred to as a peer change agent model, or a peer leader model, or a popular opinion leader model. There's a few different names that have been thrown around. These models have been deployed successfully around HIV prevention with a variety of populations since really the early mid-90s. And really for about the last 10 years or so, there's been a call to try to do this with homeless youth because of the understanding of the distrust that homeless youth often have for adults because of the negative experiences they've had in the justice system, in the foster care system, by abusive, neglectful families, and their reliance upon one another. So the way that this works is essentially in small numbers, you identify youth who will become your peer leaders. You work with them in small numbers where you can spend the time and energy needed to gain their trust. You teach them about, in this case, HIV prevention, and you ask them to go out and disseminate into their community in the ways that they often do anyway, information about the importance of using condoms, of getting HIV tested, and trying to change the norms around condom use and HIV testing. One of the challenges, though, is who to pick. Now, if our networks were small, it would not necessarily be that challenging. And in fact, one of the things that the models that started off with working with young gay men, for example, in the 90s did was they identified people who were the most popular. And in some cases, what this meant in the early days was you went to gay bars and clubs and you picked the good-looking bartenders and you asked them to be your peer leaders because everybody knew them and everybody talked to them and everybody liked them. How does that translate into a network diagram? Well, maybe those are people who are well connected in the middle of a small clique. Maybe they're people who sit between cliques. So there's groups of patrons that don't really interact with one another, but everybody talks to the bartender. And if you have relatively small networks that are relatively stable and structured in kind of sensible ways, it's not that hard to do this kind of work. But remember, we're talking about big networks, very clique-heavy networks, and it also turns out that homeless youth networks are very transient. I did some work back in the, it's getting to be about 10 years ago now, but between 2011 and 2013, where we were looking at these networks that congregated around these drop-in centers that had about 200 or 300 youth in them at any period of time. And this is actually where this particular diagram comes from, is one point in time. We would go back every 6 months and resample the entire network as sort of a panel study, and we would look to see how the structure of the network had changed and also how the membership of the network had changed. And what we found was that while there's sort of a consistent, stable population of a couple of hundred of homeless youth that congregate around these drop-in centers on any given month, the actual membership of those 200 individuals changes pretty wildly. And in fact, in one drop-in center, only 15% of the youth were still around 6 months later. And in the other drop-in center, only 40% of the youth were around 6 months later. And even among those young people who were still sticking around, many of their friendships also changed. So the actual lines connecting dots, even if the dots were stable, were unstable. So this adds a great deal of complexity. So it's a bigger, messier network, and it's subject to a lot of flux and change. So what do we do with all of that? Well, I started to work with some computer scientists on this problem, specifically Milind Tambe. And Milind Tambe is my collaborator that I started the USC Center for Artificial Intelligence and Society back in 2016. And he and I started this center in some ways as an outgrowth of the project that I'm presenting on today. So back in 2014, he and I started, we met, and I can talk about that afterwards if we've got time, but it was kind of a random meeting, and we realized that we had way more in common than we thought we would as a computer scientist and a social work researcher. And we started talking about our mutual interest in network models. And he was very interested in formal network models, which is what I'm representing here. And you don't have to worry about the math, but the point of this slide is that when you're working with a computer scientist, they're going to turn your social problem into a math problem. And so you need to learn to speak some math. And in my case, I was actually okay with that because I was a math nerd. I mean, when I was a undergraduate, which is actually kind of down the street from you guys, I was at the University of Chicago. I took, fourth and fifth semester calculus as my electives, as well as like microeconomics as my electives, because I thought that solving math problems was an easy way to get an A, as opposed to taking like an art history class where I had to read a bunch of stuff. So when Milind and I started talking, I was kind of the right kind of social work researcher for him to talk to, because while I couldn't do the math that he could do, I knew enough math that he could talk to me and we could talk to one another. And so one of the things that I will talk about this model, and then I'll move away from it, is that formalizing this means that there is a person A and a person B, and there's some probability that they're going to pass information along the network tie that connects them, which mathematicians refer to as an edge, and they refer to these as nodes. But one of the challenges that I just mentioned is that there's a probabilistic nature to whether or not people will pass along information, but there's also a probabilistic nature to whether or not that tie even exists when you're talking about homeless youth. So will that young person still be around? Will that connection still exist between those young people? And it turns out that from a computer science standpoint, this was an unsolved problem because they had been working on information dissemination in the context of Twitter networks and other sorts of networks where the connections were very stable. And you could make the assumption that, if an edge existed, that it existed. Whereas I was saying to them, we can't know for certain that my connection to my friend today is going to be there tomorrow. So even if we can get a measure of that connection, it might be gone. So it turns out that it's this ridiculously large space. So like, I'll just give you a sense of like, if $1 million, or million is a seven, so 100,000 is 6 figures, $1 million is 7 figures. This combination thing is a 157 figure number. I mean, so the space of solutions is crazy, even from a computer science standpoint. You can't just brute force try all the possible solutions. So you have to get clever as a computer scientist, which now we're way beyond my pay grade. So I'm just going to talk about it in broad strokes. And if you're a computer scientist, I'll show you the links to the papers and you can check those out afterwards and probably find out that I'm talking about them not quite right, but I'm doing the best I can. So the solution, however, works in the following way. Real world networks have cliques and community structures. Dividing our problem into these smaller structures allows us to make smaller, more solvable problems. And then we can get to a solution that is like Google Maps, where we have an optimization of who to pick. And in this case, instead of thinking about whether or not we should be, what route to get to USC, we're thinking about which small group of young people should we enroll to be our peer leaders so that we have the most efficient, maximal spread of information across this network so that we get as quickly as possible in these transient spaces filled with uncertainty, our messages about HIV prevention to as many young people who need these messages as we can. And what we found in our computational experiments, where we used my real world networks and we just did computational sort of simulation experiments, was that in fact, this new solution that Amulya Yadav, who was a PhD student at the time working with Milind Tambe, that what we found was that the new solution, which we called Healer, was way better than the proposed computer science solution at the time, which was called Greedy. Then what we realized was that we could do a little bit better and we could introduce even more challenging, more realistic constraints to the uncertainty problem and enter Brian Wilder, another brilliant young computer science PhD student who helped us solve this part of the problem. And at this point, we then said, look, it's time for us to actually do some field tests. So in 2016-17, enter my PhD students at the time, who are all now graduates and professors, Robin Petering, Jay Craddock, and Amanda Yoshiko Maxwell. And we did a test in the field where we did a pilot test where we looked at Healer versus Healer Deluxe, which was the Brian Wilder version, versus degree centrality, which is kind of how we might operationalize the most popular. So remember when I was talking about the young, good-looking, popular bartenders? Well, in this case, we came up with a mathematical way of doing that. So once we collected network data from these young people, in some cases, we ran these algorithms that gave us the optimization solutions, which is sort of like our Google Maps version. And in some cases, what we did was we just picked the young people who had the most ties. So if you are one of the top 15% of people who has the most friends or who's nominated by the most people as being somebody that is communicated with, then you are the most popular in the network at that time. And we compared the effectiveness of this with respect to information spread, as well as with respect to new HIV testing. And what we found was that the algorithmic solution worked wildly better than popularity, which frankly I was pleased by, but also surprised by that it was so much better. And what we found was that by a month out from our, so just after we had trained the young people to be our peer advocates who are disseminating messages about HIV testing and about using condoms, what we found was that we would get to about 70% or so of the people in the network who were not peer leaders would have received messages from the peer leaders. And whereas with degree centrality, what we found was that we only got to about 30%. So the popularity solution wasn't nearly as good as splitting things into cliques and picking people that had the ability to spread information maximally within those cliques, as opposed to sort of overall who's the most popular person, kind of in the context of like a bartender. And I'll talk about, you know, kind of what that might mean a little bit more, but I'll just kind of pique your curiosity with, well, why would this work at this point? And then what we found was, you know, in terms of behavior change, that we found that there was some, behavior change that followed suit. So people that needed to get an HIV test who had not been tested at baseline, we found that there was much higher rates of HIV testing amongst the people that were in the AI version of the study than the people that are in degree centrality. Now, but remember, this is a pilot test, right? Where you saw the slide before this where, you know, numbers are, you know, 60, 56, and 55, right? So statistical significance is out of the question. But the other problem is, before we go running off to do a big, expensive clinical trial, is that we learned that there were some problems when we tried to deploy these algorithms. Now, I saw that there was a hand raised. Gaurav, should I be answering a clarification question real fast?
No, this is around
Okay.
How do you engage social work students? So maybe at the
Okay,
end.
so I'll do that toward the end. Cool. Yes. So one of the short answer of this that I'll give you is the social work students were actually the PhD students, and this is a master's student of mine at the time who was an intern, were actually the folks who helped me develop the actual training and actually conducted the intervention work with homeless youth. These are actually two of the actual backs of the heads of the two real peer leaders that we worked with at one of the drop-in centers. And so these folks are integral to the face-to-face parts of this, not the algorithmic parts of this. But I'll talk about more about that at the end. So one of the first problems that we discovered was when we were given a list of, here's the people that the algorithm says that we should pick. My social work MSW students called back from the field and said, and PhD students who are out there with them said, Eric, so we can, you gave us this list of 4 people to invite to this training for this week, but we can only find 2 of them. And so the challenge there was that the algorithm gave us this optimal solution, but it had unfortunately made the assumption, because we hadn't thought of it ahead of time, that, we might have seen this young person 2 days ago when we recruited them to the study, but homeless young people are really, really transient, and we might not be able to find them again, even, 2 days later or a week later. So what do we do about this? Well, we tried to design a new algorithm. So now we designed an algorithm where what we did was there's 2 actions. So, in the way sort of practically this worked was that the computer science student who's got an algorithm in front of his desk, in front of his laptop, is making a call to my MSW field staff and saying, okay, I've run the algorithm and I'm looking for these 4 people. Are any of them there? And then the person who is on the other end of the line looks around the drop-in center, reports back on how many of those people are there, lets Amelia know. Amelia enters in that information, runs the algorithm again, queries it to say, is that a good enough group of young people available? Should we use this group, or given who's there, should we try again? And what's interesting about this is that it took advantage of some real-world observations that my field staff made, which was that basically, when we recruited young people into the study, we asked them who their friends were. That's how we created the data to use to try to run into the algorithms. And one of the things that we found out was that people tend to come and go with their friends. right? Like if I've got a couple of friends that help keep me safe on the streets, I tend to run with them day in and day out. If you're looking for me, and and I'm not there, probably my buddies aren't there also. So this was part of how and what we did was we did again some real world testing of this with some networks, and then Laura Onishvera, who is my my MSW former intern, now project director at this point in the study, was actually testing it out in the real world by this field experiment of looking for these people and determining who we could find versus who we couldn't find and how well would that work. And we found that this algorithm was better. Now, what ended up happening though in the midst of doing that was that what we realized was, man, it is going to be really hard for our community partners to collect all of this network data. And that is going to be a problem. It's expensive and costly. And it turns out that even the agency staff don't know very well how young people are connected. And my staff as observers also don't know. So what I'm going to show you here is network A is the combination of all the networks combined and the ties that exist between them, which, as you notice, looks more or less like network B. Now, network B is the self-reported connections among the youth during this particular one wave of data collection that we did. Now, letter C is the observations which my staff made during that same time. I said, hey, why don't you guys look around and tell me who you think is friends with whom? And as you can see, it was kind of a lousy representation of the network. Then I asked a staff member who knew the youth very well to describe to me the connections among these youth. And it was better than my staff's version, but still missed a lot of connections between these young people. So the lesson learned from this is we need to come up with a way that will make it so that we don't have to collect all of this network data, because we can't talk to every single young person before we deploy these algorithms. That's just too much effort for a community-based organization to actually, collect network information, because it would take us a week to get from the 100 young people that we were trying to recruit in a given week, all of their network ties. And we can't depend on adults to look, on high and know what the relationships between young people are, because we're just wrong. So what we did was, and this is a slide showing the math of that, the actual. So what we did was we created an algorithm that first samples a small number of youth, asks them to tell us who their network ties are. We then sample from that set of ties, and we ask them who their friends are. So now instead of asking 100% of the network to tell us who their ties are, we only had to ask 1 in 5 or 20% of the network. So in this case, instead of 100 young people, it was 20 young people, which felt like a much more doable level of engagement. And what we found when we did that was that this new algorithm, when we compared its solutions in computational experiments compared to Deluxe Healer and the original Healer, was that while it was not as optimal of an optimal solution, it was pretty darn close. So this is kind of the equivalent of saying, if you were to ask Google Maps to give you the best route from LAX to USC campus, and sometimes, and 70% of the time it's going to be right, and 30% of the time it's going to give you choice number 2 or choice number 3, but most of the time it's going to find the good thing, versus 90% of the time it's going to get you the first choice, but it's going to take like 10 minutes for the algorithm to download and give you the information about which route to take. You as a driver would probably say, forget the 10 minutes. I'm going to be 10 minutes down the road by the time I even get a solution. The 70% choice that's going to give me maybe choice number 2 is good enough. And that's kind of the calculus that we went through when we decided to go with, in the end, the change algorithm. So this is the algorithm. It's really version 4 of algorithms that we tested in a large real world pilot study. So what did we do? Okay. enter one of my dear colleagues at this point. She's now been working with me since 2016. Laura Onishvera, who started off as an MSW intern, became my project director and oversaw the collection and recruitment and training of 700 youth. And so what did she do? Well, in conjunction with former PhD student Robin Petering, who really did the heavy lifting of intervention design refinement. I'd love to say with me, but it's really more for me. She's a wonderful clinician, far more skilled than I am. And we created an initial 3 to 3.5 hour training that was conducted by 2 co-facilitators who are usually MSW interns. And the training components for our peer leaders are sort of 6 things: framing the peer advocacy mission, HIV and STI education, communication skills building, leadership skills building, and self-care. And then what we would do is we would meet with these young people for the next 7 weeks, once a week for about an hour. And we would do a lot of just, positive reinforcement. I mean, there's really some basic just behaviorism stuff going in here, right? Like young people would come to us, we would applaud their successes, we'd help them brainstorm around their challenges, set realistic goals for the next week, send them back out into the field to continue to do their outreach work around promoting the use of condoms and the use of regular HIV testing. And we would really encourage these young people not to engage with strangers, but to engage with their friends, and particularly other of their social contacts that were young people at the drop-in center, because we explained to them that that's who we were tracking to understand how well the study was working. And we really discouraged social media work. What we found was that young people in this context, while they are very connected to the internet and to social media, that's largely a mode of communication they use to communicate with friends from home and family from home. And with one another on the streets, it's still face-to-face communication that is the main mode of interaction with these young people. So these are the three drop-in centers that we worked with: Safe Place for Youth in Venice Beach, My Friend's Place in Hollywood, California, and the LA LGBT Center in Hollywood, California. And this is the study design. So we had an AI arm, which had 253 young people enrolled in it. We had a degree centrality arm, which was, again, that popularity arm. It had 200 youth. And we had an observation only arm, which had 251 youth. Now, because you cannot randomize within a network where you're trying to disseminate messages, because the point of a dissemination campaign is to connect people and to have that, essentially, that bleed over. So in a clinical trial with oftentimes for, say, like depression, you'd recruit a sample of 100 young people or 200 young people. You'd randomize them to the intervention, the new therapy arm, and then the treatment as usual arm. And you'd hope that the young people in the treatment arm don't teach the young people in the treatment as usual arm too much of the new skills that you're teaching them. In this context, the whole point of the intervention is for the people who are not recruited by the algorithms to teach the other folks about things. So what we had to do was really a quasi-experimental design, wherein what we did was, since we had these 3 different drop-in centers that have slightly different populations, we went to each of those drop-in centers once every 6 months over the course of about 2 years. And remember, from the previous work that I talked about, 6 months gives us a time for those populations to kind of cycle through. That then what we were able to do was we would do a particular arm of the study at a particular point in time in a particular drop-in center. So what we really ended up having was 9 different recruitment periods. So you were either recruited into the AI arm at Safe Place for Youth, or into degree centrality at the Youth Center on Highland, or the observation only arm at My Friend's Place, and all 9, so the 3x3 combination was there. which led to this. Now, one of the downsides of working with homeless youth that are at drop-in centers is that most of them are actually living on the streets or in emergency shelters, not in anything close to stable living situations. And so attrition is an enormous problem, although something that has been seen in other studies. So I mean, this is it has been seen in the literature before when you're recruiting in this way. But by the time we got to 3 months follow-up, we only had 60% of our sample left. So it's rough working with this population for sure. Incredibly rewarding. They're wonderful, wonderful young people, but it is difficult work. But what's incredible here is that things actually worked out well. So here enter some of my current PhD students who helped me with the data analysis side of things. And what we found was that, in fact, anal sex without a condom was reduced in the context of statistically significantly over time. And what we really see is that it's a more rapid reduction. So by 1 month, the change in behavior happens. So when you're looking at the AI arm versus the most popular arm, where up to 1 month, things are relatively stable. And then afterwards, things by 3 months, things go down. So what that means, again, kind of thinking about the pilot study, is that information is spreading more quickly through these networks when you run these algorithms that are trying to maximize a solution wherein you can get the biggest reach the fastest, right? So we're solving for a problem, which is how do we get to people the fastest? And then it works. Vaginal sex without a condom, we saw reductions over time. It wasn't statistically significantly different across the AI and the most popular arm in this case. And here are the GEE. So this is our the standard way of doing longitudinal statistical analyses over time. What you want to see is the intervention arm by time interaction effect as significant as we do with condomless anal sex. So you can see that was a win here for us. What you see with respect to condomless vaginal sex is that it's marginally significant. What you see with respect to HIV testing is that everybody in the final study in all arms got better over time. But what was interesting was that the peer change agents over time, so the young people who we trained and really spent a lot of quality time with, they actually, their behaviors changed statistically significantly over time. And our hypothesis is that the pilot study results were really reflecting maybe some of the close connections that these young people had to those other folks. Or maybe it was just that we got lucky in the pilot study. I mean, that happens too. Also, HIV knowledge over time turns out to be something that is increased with the peer change agents themselves, the young people trained to do the intervention work, but not actually in the larger population, whereas these are the young people in the larger population. So we see some really promising intervention results here. So why did this work? All right, so I'm going to talk about what I refer to as the Breakfast Club versus the high school football team. So to reflect my age, there's a movie in the 80s that was popular when I was a teenager called The Breakfast Club. And in this, what the premise of the movie is that there's these 5 kids from these 5 different social cliques. You've got a stoner, a jock, a goth, a princess, and a nerd. This is me over here in the corner. And they come into an all-day detention. They're from these different social cliques. They become friends for the day, bond, kind of do their thing. And then at the end of the movie, they all go their separate ways. That is the dynamics that we saw with the peer change agents. They were from different social cliques. When they got together with us in the training sessions, they were very focused on the work of the day. They bonded with one another. And then at the end of the day, they went back out to their social cliques and spread the word within their local communities. Versus Degree Centrality, which was basically the high school football team. So the most popular kids, the highest number of ties. But the problem with this group is that 2 things. 1, a lot of their connections are to each other. And 2, Their other connections are to kind of the hangers on of their clique, right? So if you're talking about the jock over here, right? Like he might have known, and I think in the movie he knows the princess, but he doesn't know these other three, right? So his information is going to spread to her. Maybe someday her information is going to spread to him because he like tutors her or something like this in the movie. But really the communication breaks down pretty quickly. And so what you have in the context of homeless youth is not a bunch of guys that play football, but actually in the pilot study where we did degree centrality, I actually ran the sessions, and it was this posse of skater bros who would hang out on Venice Beach with their skateboards, getting into fights, smoking a lot of weed, kind of tough guys, drank and used a fair amount, very well liked in general. But one of the problems was that not everybody liked them. They didn't like everybody. And they knew they were really tightly connected to one another. So when we did the intervention work with them, they brought all of their 20-year-old testosterone-fueled adolescent male nonsense into the sessions and made it really hard for us to do the work with them and bond with them, which I think is partly why they were less effective. So they themselves didn't get as much out of the interventions, and then they weren't as good at spreading the word because they weren't as well connected to little microcosms of the universe of homeless youth. So if you would like to learn more about this, a few places you can check out. One is a book that I edited and published with Milan Tombe. It came out 2 years ago, called Artificial Intelligence and Social Work, where we talk about this and about 10 other studies that were in their infancy at the time, where we were trying to bring social work students who are PhD students and computer science students that were PhD students together into teams working on real world problems. And these are really all a bunch of pilot studies that were published in this book of these. There were about 8 teams that worked on stuff, plus a bunch of the work that I just talked about here. So it's a really cool book if you're interested in seeing the evolution of these interdisciplinary teams and really what PhD students can come up with. It's pretty amazing stuff. And then if you want to learn more about the work that I just talked about, we published a lot of papers on the algorithm development, as well as papers on the field tests, including a paper that came out in the Journal for the Society of Social Work and Research about 2 years ago this fall, that produced the pilot study. And the current field test of the clinical trial is available on archive.org, which is out of Cornell, or you can wait for it to get published in the peer-reviewed literature, which hopefully will be sometime soon because it's under review right now. And with that, let me thank my funders, especially the California HIV/AIDS Research Program, which gave us almost $1 million to do the large-scale study, and Milan Tombe, who led the AI side, even though he left me for Harvard a year and a half ago. Thanks a lot. I'm happy to take questions and probably say other off-the-cuff silly things.
Thank you, Dr. Rice. We have 2 questions.
Okay.
Do you want me to read that to you, or do you want?
Sure.
Okay. So one is by anonymous attendee. They are asking, how do you engage social work students and practitioners to understand the importance of looking at or learning about such unconventional intervention frameworks, such as AI for addressing homelessness, when there is a larger perception or belief that technology is devoid of humanness that is seemingly a crucial component of social work intervention?
Yeah, that's really interesting. I have two kind of different answers for that. So from the perspective of the providers, the way that I was able to get them interested in this was that I had, by the time I got around to doing this, I had been working with those 3 providers for 12 years or something like this. So, I mean, they knew me, they trusted me. We had done a number of studies about the ways in which homeless youth use technology like social media and cell phones to communicate with family and friends and agency staff, et cetera. And so there was a lot of trust that had been built by me so that they were willing to sit and listen to me talk about what I perceived to be the potential benefit of thinking about a technology-driven solution. So trust. with the community and engage, and, you know, doing, you know, I used to, early in my career, I would, you know, before the pressures of, you know, tenure track life got too much, you know, I used to do volunteer work 1 day a week for a whole day every, you know, for about 3 years when I was, you know, first, you know, out of my doctoral program, you know, and first moved to LA. I mean, you know, in these agencies, you know, when we do community-based work, we always work as volunteers for a month or two before we start to you know, do our data collection, just so that we can again reinvigorate trust with the agency collaborators and the youth themselves. So that's part of it. But the youth themselves actually trust technology more than they trust people. So I remember when I did a version of this work where human beings were making the decisions about who got to be a peer leader back in about 2010. And young people would get very upset when they didn't get selected to be one of the peer leaders, because they wanted that attention from adults. They wanted the extra incentives that you would get from it. When we deployed the algorithms, what we found was that when we explained to young people that humans aren't going to pick you, it's going to be a computer program that's an algorithm, this AI algorithm that's going to be taking the network data that we collect from you about who your friends are, and we're going to feed it into this program. It's going to spit out who should be the peer leaders. First of all, they thought that was kind of cool. They're like, oh, that's cool. You're testing out a new AI with us. That's kind of cool. And the second thing that they found out is when we said to them, I'm sorry, when they said, I want to be a peer leader too, and we would say to them, I'm sorry, the computer didn't pick you this week. To them, they were like, all right. It was sort of like an impersonal rejection. It's like, the computer doesn't get me. You know, algorithms are wrong all the time. Sometimes they're good at showing me the ads I want to see on Facebook, and sometimes they're stupid. This one just doesn't understand how important I am. And then there was like it wasn't offensive that, you know, that a computer missed them somehow. And yet it was kind of cool that so like, if the computer picked you, you thought it would, the young people tended to be like, oh, cool, that's cool, I got picked. But if it didn't pick you, it was like, ah, the computer just doesn't understand how cool I am. Which I didn't think, but I think that digital natives, which is sort of how people sometimes talk about, you know, the, you know, young people that are, you know, young enough to be children of mine, think about technology. You know, it's not the way that, you know, old fuddy-duddies with gray hair like me, you know, think about those things. So, whereas the agency partners of mine, who are all the other people that are middle-aged, like, they're the ones who we had to convince that this was not crazy. The youth themselves were like, yeah, this is cool, go for it, you know? So what was the next question, and see if I can.
Second, thank you, Dr. Rice. Second is from Daniel Ortiz, and he is asking, when you talk about networks, I'm wondering if you took into account the level of influence of a particular network member or group as a way to predict efficacy. I'm thinking about ways to measure how information can become optimally actionable.
Well, you know, in this particular study, we had a very, very simplistic vision of networks and communication, because it was one of the, it was the first time that we had tried such a thing. And so really we weren't thinking about, you know, all we were thinking about was, is there a network tie? And is the person who's delivering the message connected in ways that are important? What we did subsequently that I think was really interesting and important was we did a violence prevention intervention. And so this is a Robin Petering PI'd intervention. And she, you know, what she did was, she, having seen what was happening with the field test that she did for me, said that what's important is whether or not a young person wants to be a peer change agent, not just how they're connected, and wanted to have information that was more easily actionable, as the commentator suggests. So what she did was, she built into the initial survey not only who are your friends, but would you like to be one of these peer change agents? And she had a number of questions about how engaged in violence were you, and also how much do you trust adults, and how interested would you be in being a part of an intervention team. And so she factored those bits of individual information into the algorithm. And then she thought that, getting an HIV test or using a condom is kind of like a distal outcome. It's like, I have a conversation with you, and then maybe you're going to do something down the road. And so what she said would be better is if one of the main asks of these youth, so what she was doing was a violence prevention intervention, and the therapy around it was around mindfulness and yoga. So one of the main asks of the Pure Change agents was to go out and invite a friend or two of theirs to come in and do meditation and yoga for an hour with them. So it was a much more actionable ask. And so, I think that one can be much more thoughtful about just this sort of thing, about like, who are these people and how are these networks going to function, and not just kind of the more kind of dumb, math geometry of networks that we looked at in this initial study. And not surprisingly, her intervention results were way better than ours. Like the effect sizes were like ridiculous. I mean, I think that there's real potential to this. Ethical considerations as research evolved from before and after the use of AI. Yeah, AI has made me think about ethics a lot more than I used to, especially about issues around fairness and bias. This is what my new AI-driven work is really about, is around housing allocation and whether or not the housing allocation systems that are in place in communities are actually aggravating systemic racism, which is absolutely a part of the experience of homelessness, and also systemic homophobia and gender violence and all sorts of other horrible sort of forms of discrimination and prejudice and violence that exist in our society. And can we use AI to, first of all, if you don't think about these things well, you're going to create AIs that make those problems worse. However, you can also use AI to look for those problems, those sources of bias, and then to mathematically try to correct for those problems, insofar as even sort of simple ideas like one should not create models that learn the outcomes for Black people experiencing homelessness based on data from white people, right? Seems like a really simple thing to do, but if you just throw in all of the data in your system and your system is disproportionately white people, guess what? The parameter estimates are based on white people more so than Black people. So you need to really think about these sorts of questions, and it's really opened up. I think a lot of times as social work researchers, we think of it, it's like, we have this code of ethics from the NASW, we really adhere to it, we have IRBs, we adhere to these things. AI opens up a whole new universe of problems that we were either absolved from because we didn't have to worry about them, because we weren't creating algorithms that kind of make decisions on their own, and we didn't have to worry about what the outcomes of those things were, or we were just kind of, I don't know, naively thinking that we were doing, because we're well-intentioned people doing a good job. And I think that there's a lot of skepticism about computer scientists doing this social good work, and so there's the microscope of ethics that's placed to this can be a lot more intense than what you get as a social work researcher. So, see, it's 11 o'clock, so I should probably shut up. Yeah. So thank you.
And it's 1 o'clock Central Time. So thanks so much, Eric, for coming and sharing this work with us. It's really fascinating. I think it will point people in a lot of interesting directions, and we appreciate your time very much. Thanks to all of you who could come today as well, and I wish you a happy rest of the day. This talk will be available by recording also, so please feel free to share it with your friends, and we'll be happy to make it available. So thanks again.